Salutations and welcome to Space Time Continues. My name is Mary Louise Davey, and let's get going to space.
T-minus 10, 9, 8.
Space.
T-minus 10, 9, 8, 7, 6, 5, 4, 3, 2.
But first, let me cover a couple of stories. Are we all Martians? Could be. Of course, as usual, we have to go back to the beginning. Fact 1. More than 3 billion years ago, Mars had all the necessary building blocks for life. To be honest, Mars and Earth were very similar. Actually, Mars was more Earth-like than Earth was at that time. So, Curiosity, our geologist on the spot on Mars, is capable of so much. In fact, it can use a laser on a rock 23 feet away. It can drill for samples. It can examine them in its own on-the-spot lab. So, I mean, each rock it finds, each pebble, if it's round and curved, we know it's been around water. So yeah, it can find out a lot. Curiosity finds out a lot about Mars for us. So basically, Curiosity has found the essential and organic chemicals that helped us arrive to the decision that Mars could have supported life. Okay, so then, join me if you will, on this wonderful voyage. Here we are on Mars. A meteor comes flying through the skies and onto Mars, slams into Mars, makes a rock jump up and into space, and now that rock, it goes on a 33.7 million mile trek out towards the sun, and eventually into Earth's orbit, and eventually that orbit decays, and it goes down through and lands on Earth. Well, rocks from Mars are often meteorites. They often land on Earth, right? Well, what if that rock had some microbial life on it? And what if that life is what crawled out of the water and walks now on 2 legs on Earth? So, are we Martians? Could be. Could very well be. A space geek's dream. So, SpaceX is selling satellite launches to companies, sending cargo back and forth to the ISS for NASA to fund its mission to perfect reusable spacecrafts and rockets, and ultimately to get to Mars. SpaceX has accomplished a lot in the last 8 or 9 years, and it is without a doubt a space geek's wonder that in this short time Elon has accomplished the following: include the first privately funded liquid propellant rocket to reach orbit, which was the Falcon 1 in 2008, the first privately funded company to successfully launch, orbit, and recover a spacecraft, that's the Dragon in 2010, the first private company to send a spacecraft to the International Space Station, the Dragon in 2012. The first propulsive landing for an orbital rocket, that's the Falcon 9 in 2015. And the first reuse of an orbital rocket, that's also the Falcon 9, and it's in 2017. As of March 2017, SpaceX has since flown 10 missions to the ISS under a cargo resupply contract. NASA also awarded SpaceX a further development contract, which would be used to transport astronauts up to the ISS and return them safely to Earth. You see, back in 2011, SpaceX announced that they were beginning a privately funded reusable launch system technology development program. In December 2015, a first stage was flown back to a landing pad near the launch site, where it was successfully accomplished a propulsive vertical landing. This was the first such achievement by a rocket for orbital spaceflight. Then in April 2016, with the launch of the CRS-8, SpaceX successfully vertically landed a first stage on an ocean drone ship landing platform. In May 2016, another first for SpaceX, and they again landed a first stage, but during a significantly more energetic geostationary transfer orbit mission. In March 2017, SpaceX became the first to successfully relaunch and land the first stage of an orbital rocket. So it would seem that the accomplishments are beyond what was credible, and now Elon Musk can rest on his laurels, right? No, he's got a lot more plans. So what? Well, in September 2016, Elon first laid out his crown jewel, the Interplanetary Transport System program, a privately funded transport system, a taxi service, if you will, to Mars, that he hopes to lead to sustainable human settlements on Mars over time. In 2017, he announced the company had been contracted by 2 private individuals to send them in a Dragon spacecraft on a trip. They're going up into orbit around the moon, a free trajectory, provisionally launching in 2018. So this will be the first instance of lunar tourism. The launch that I'm showing you today is SpaceX Inmarsat launch from their Florida launch site. As you may recall, they're using that launch site that used to be Apollo's, the 39A. That's quite fitting because they're the next generation of that same spirit that we would love to embody. We'd love to see that spirit where everybody was enthusiastic and wanted to watch every launch, couldn't miss a thing. Well, that's what SpaceX is bringing to this new generation today. So, okay. Now, after this, what is this that's so important? Why is this launch so important? Because it's another step on the step to what they have planned. The Falcon Heavy, the going to Mars. All these plans rely on starting with this. This was one of the heaviest launches. This is why we're not seeing a second drone ship land, is because this launch took up so much mass just in the launch itself, in what they were launching up. So, okay, that's the first stop, but there are another step and another step. All the paths that their founder, SpaceX's founder, has tripped. So, enjoy the launch.
T-minus 10, 9, 8, 7, 6, 5, 4, 3, 2.
This is our goal, our destination, more than 100 million miles from the sun and tens of millions of miles from Earth. We plan to colonize. We want to. We will. Mars really eventually is the plan, but likely that will begin in a testing area around the moon and cislunar space. So, and here's what I'm talking about. It's 4 missions carrying all the gear that goes on to Mars, and it'll be sent up to the moon. Now, these missions would be between 2018 and 2022. The thought is to test by spending time in cislunar space, or in the anticipated travel time of 1,000 days, in cislunar and the orbit of the moon. Spending 1,000 days up there in space, humans on the journey, traveling around in the orbit of the moon for 1,000 days, as if they were traveling to Mars. And that's how we'll test it all out. Well, I can hear some of you already say, well, we've been to the moon, what's going on? We already know how to do this. Come on. Well, it comes down to a couple things. The trip we're talking about is 33.9 million miles. So to help you better picture this concept, figure going from New Jersey to California to New Jersey again. Well, if we were going the 238,000 miles to the moon, you'd only have to do that about 42 times. But if you're talking about going to Mars, it's 33.9 million. So now you're talking about 14,378 round trips from New Jersey to California and back again and back again and back again and back again. So rather long. You can't just take the nearest jug handle because we got to get some more fuel. We got to double back. We got to go get this. Oh, this isn't reacting well. No, you can't. So better to practice it in the orbit of the moon. Get the trip perfect. Make sure we can handle all the emergencies that pop up, because you know there are going to be some. And then we can do the trip for real. And when we do the trip for real, the emergencies that pop up won't be the same emergencies that did on the close by trip, but now we're better prepared to handle the whole trip, to handle these emergencies. And maybe some of them will be duplicates, and we'll be like, I got this. So going to Mars, first we have to travel a long way right here. We have created a bubble, if you will, around the Earth. We have created sort of like a shield. And you thought we already had a shield, right? Well, we do. It's a magnetosphere. It's formed by, inside the Earth, inside the ore, the iron ore center, there's liquid going around. And that helps form the magnetosphere, which extends thousands of miles out into space. And that prevents the solar wind, the protons and electrons emitted by the sun that travel through the solar system. Now, the magnetosphere will deflect most of the charged particles and shield our planet's surface. But when the IMF field lines and the geometric field lines are not parallel, the solar winds, well, there's a path to leak into the upper atmosphere. VLF. What's that mean to you? Something come to mind? Well, they're very low frequency waves transmitted from stations on the ground. Say there's a submarine in the Arctic Ocean that they'll come up to the top of the, to the surface, and we'll have communications with them. Or anybody on any country wants to have communications with their sub, and their sub has to come up. So we're talking VLF, very low frequencies. So what does this have to do with us? Glad you asked. NASA announced last week that a pair of NASA space probes have detected an artificial bubble around the Earth that forms when radio communications from basically anywhere around the globe interact with high energy radiation, the particles up in space. So basically this means that in addition to our magnetosphere, the planet is also protected by our own bubble that we've created from any of the solar winds, solar flares, coronal ejections. Any of these things can cause problems to our radios, our telephones, our energy grids, anything. So having two bubbles up there is certainly, two are better than one, right? But man-made. It's interesting. So there was this robotic mission that found them, was launched up in 2012, and it was going to look at the Van Allen radiation belts. Now, a radiation belt is a zone of energetic charged particles, most of which originate in the solar wind, and is then captured and held around the planet by the planet's magnetic field. The Earth, it has two such belts. And sometimes others may appear and then disappear and appear and then disappear. It's all temporary. So what about this? Well, science say that the edge of the outer artificial bubble lines up exactly with the inner edge of the Van Allen belts. This suggests that VLF, or very low frequency waves, can push radiation away. Seems to me we might have something here. This is a happy accident, no? Because it might point to additional methods to protect our astronauts and ultimately us when we go into space, right? But I'm getting ahead of myself. So, humanity's doomsday seed vault, bet you didn't know we had one. Last week, there were alarming headlines regarding the Svalbard Global Seed Vault. Climate change had apparently breached this fail-safe trove of the planet's seeds that's supposed to protect Earth's food supply in the event of, well, doomsday. So, this alleged failure of the vault buried deep within an Arctic mountainside, it occurred after a warmer than usual temperature, and it basically caused a layer of permafrost to melt, leading to meltwater pouring inside the entrance in a tunnel, and putting basically the most diverse collection of seeds at risk. Now, this vault is taken care of by the Norwegian government. Construction of it cost about $45 million. That's $9 million actually US dollars. And storing seeds in the vault is free to end users. And with Norway and the Crop Trust paying for the operational costs. Now, the primary funding for this trust comes from organizations such as the Bill and Melinda Gates Foundation and others, of course. So what happens is, as I say, it's operated like a bank. People check in all their seeds. Nobody has to pay anything, though, but they all check it in. But it's their material. It's a Norwegian building, but it's their material. And then they just check it out if they want to take their seeds back. So all seeds are in there going back tons and tons of years. There are seeds in there for every possible plant. So maybe 20 years from now, that plant doesn't exist anymore. That can be pulled out. So what am I saying? Nothing, basically. This is being taken care of, but it is interesting to see the reach of climate change, and kind of interesting because not really something we expected. Do you remember that star in the news a while ago? Alien megastructure. We don't know what's going on. Strange dimming of this one star. Strange dimming and brightening, and not on a Tadaka type beat. Just, So it's a perplexing cosmic object known as Bajorgen's star. And as I say, once again, it's acting very strangely, and that dimming and brightening is occurring, one which scientists have tried to explain with hypotheses ranging from swarm of comets to alien megastructures. In fact, on May 19th, an urgent call went out to scientists around the world to turn as many telescopes as possible towards the star to try and crack the mystery of its behavior. The star, there was a lot of tweets you could see about it where it's saying, hey, this star's doing it again. The star, is it in its ingress? There are all these questions shooting across the people around the world changing their telescopes to catch it. So since the brightness and flickers displayed by Bajorgen don't show the kind of regularity typical in a planet's orbit around its star, scientists had to look elsewhere. But it also doesn't seem to be able to be explained by a system of planets or, as I said, a swarm of comets passing in front of the star, or that it's a result of a strong magnetic activity, or some massive alien structure. But no leading hypothesis has emerged. So scientists have sought to capture a highly detailed picture of light coming from the star during one of these dimming periods. It's a detailed view in which scientists typically call an object spectra. It can reveal things such as the specific chemical elements that are in a gas. Also might tell scientists if an object is moving forward or away from the observer. Basically, we want to figure out what is going on. But in the meantime, it's kind of a cool thing not to know. I mean, it's kind of a cool mystery. Maybe we've got aliens and they're out there, because we've seen this dip in light and such out there a year ago or 2 years ago, and we're seeing it now. And I don't know if there are the similarities between events or if they're both completely different, because I imagine if they were similar, the scientists would have picked up on that. So this is a great mystery indeed. But it just might be maybe an alien's New York City. But, you know, we've got time. Wait it out. It'll happen again and again and again, and in between we'll figure it out. Oh, and FYI, Boyajian was the astronomer at Yale University who led the team that initially spotted the star's brightness fluctuation. NASA's latest mission could crash the world's economy. That's pretty interesting, don't you think? NASA has set the date for a trip to an asteroid that could be worth quadrillions. The Discovery mission will launch in the summer of 2022 with a planned arrival date at the main asteroid belt where the space rock that is it's located there. It should arrive in about 2026. That's 4 years earlier than the agency's initial plans. Now, the asteroid, called 16 Psyche, is a massive hunk of precious metals, including platinum and gold, as well as iron and nickel. It orbits between the Sun, Mars, and Jupiter, and basically it's of great scientific interest because it holds clues to one of the earliest eras in the history of our solar system. Less than 10 million years ago, after the birth of our sun, but now it's grabbed the attention of money-hungry entrepreneurs and investors, thanks to its stratospheric price tag. Valued at 10,000 quadrillion. According to Lindy Elkins-Taunton, the lead scientist on the NASA mission, it is definitely worth more than its weight in gold. But bringing back an asteroid of this value would crash our economy completely. Luckily, the space agency is taking the trip for scientific purposes, and it isn't really planning on a treasure hunting expedition. It's not conducting really any mining yet. It reckons 16 Psyche is a survivor of a violent hit-and-run collisions between planets back when the solar system was just forming. That, of course, means it could tell us how Earth's core and the cores of other terrestrial planets were formed. So, what could be done with that? Right now, we just go and look at it and come back. But there are teams, there are companies out there who are going to go, Planetary Resources is one of them. You know, companies that want to go out and mine these asteroids and such for work. You know, bring back all the resources. Well, if bringing back the resources just from this asteroid would totally explode the world economy, then how's that going to happen exactly? How are they going to be able to do it in the future when they go to multiple? So theoretically, there'd be multiple tens of thousands of quadrillions brought back, and it's something the economy can't handle. So maybe we have to plan ahead for this. Maybe we have to think about this. But we only have so much time. So I'll see you next time when Space Time continues.